Ahora, no, es que pensaba que podía. Sí, pero. Bueno, intentaré.
Yeah, for the lightning.
Yes.
Okay. Okay.
Okay, so maybe let's get started. So first of all, thank you so much for coming now and for coming here to this EuroSciPy edition. Yes, at the beginning, if you have a minute, you can just scan this QR code and give us your feedback. Anonymously, we will really appreciate it. To know where and how we can improve. And yes, and now it's time for our sponsor announcements. So, yeah.
Would you like to plug?
Yes.
Here.
It's already working.
Okay, so I have the honor of introducing one of the sponsors of the conference, namely MVPI, the company that I work at. So who are we? We are one of the largest open access publishers in the world. So we publish scientific publications, and like our hallmark is that it's open access. Everything that we publish is open access, meaning there is no paywall. Everything that's published is freely accessible by anybody. And open access then implies that it's also open science. And on a similar token, we also want to support open source. This is one of the reasons why we sponsored this conference in 2025 in Krakow. And we have more than 300, or actually we have more than 500 journals, but over 300 of them are indexed in Web of Science, so you will get all the citation credit when one of these journals cite your publications. We have an office here in the city, and we have a very fast-growing AI and data team. We're building a new team here in the city. We have another one in Basel. This is where I work, and we are looking for more people. So one of the projects that we have is Cited. It's a database for researchers that stores basically everything that is published in the world. It contains 180 million published articles, at least metadata, and it contains 550 million authorship relations and over 2 billion citation relations. So from a data point of view, this is a very interesting data set to work with, to apply data engineering, to build metrics, and advance also science. Our tech stack is Python, Polars, Postgres, DuckDB, and also Airflow. I think you had a chance to talk to the staff at our booth. You probably also were able to receive a cup. If you're interested about the positions, we still have flyers, or reach out to me. Thank you.
Thank you, Frank. And next is Janos from Applied AI.
It's still some kind of responsible. Yes. Or groups. It is what it was supposed to be. Okay.
So, yeah, you can see this. Yeah, I'm Janos from Applied AI. Applied AI is a small German non-profit working in AI teaching, research, and open source software. If you're interested in applied AI, you were probably at our booth in the last 4 days, so I'm not going to say very much about it. But we still have the result of the lottery to announce, so you can win a keyboard if you answer the following quiz. The quiz was, we have a class A that has a gap error, that raises an attribute error. Then we inherit from A in a class B, and the question is like, what happens if we run b.bar? Out of the people who participated, we were very divided on option A and C. So A means attribute error foo, so what happens is the code here, and the other said, okay, it's attribute error bar, so what matters is the name of the method. Those who, a few people also said infinite recursion. So what happens is we get the attribute error bar. So those who had the other answer did probably not see the property decorator. Property decorator does a bit more than just removing the need for brackets when you call the method. It also does a bit more. And now the more important part is who will win the keyboard. So we collected all the GitHub names and will now randomly draw a name. If the person is not here, they don't win a keyboard and we draw again. So let's see. It's all very transparent because we really don't want to have any complaints afterwards. So, is gap? Yeah. Congratulations.
Thanks a lot.
Okay, thank you very much.
I will manage it as it say. It's another one. This one doesn't have.
Okay, so now we will start our lightning talks section. So the first one to go is Lucas. So you can get ready. And just to remind you, the rules is like 5 minutes max, unless it's a conference or event announcement, then let's try to stick to 2 minutes. Thanks in advance, and the floor is yours.
Okay, we're going to do some live coding of untested, unmerged stuff that I've been hacking around the past few days, and also lots of other people at Prefix have been working on. So yeah, it will be a miracle if it all works, but we'll see. Specifically, we're making Python evil with Pixie build, making NumPy evil, I guess, too. So Pixie, it's a package manager, which means it handles packages and it handles environments, and environments in those packages, kind of a replacement for Conda and pip, and it uses UV. You can kind of use it instead of UV. So yeah, here's a very simple environment. We just have NumPy, Python, IPython. IPython is coming from Conda Forge, but NumPy and Python, we're actually building them from source. And that's kind of a scary word, especially if you contribute to projects like SciPy. But Pixie makes it all nice and easy. So this is our environment source. We can run things in this environment. So just like spin up IPython. And I've already built things, so it's like really fast now. Yeah, if we want to import NumPy, sorry, I'm doing this with one hand. And then like this should just be normal NumPy working nicely. We know exactly how NumPy works. But fortunately at the conference we had a handy NumPy maintainer on hand called Sebastian, who was able to dig out this file here. And if we meddle in this, we can make some strange things happen, like swap, subtraction, and addition, specifically for very small floating point arrays. So we do this now, and then we just rerun our IPython. And okay, let me make this verbose so that, oh no, we have no internet connection. Do we need to, no, it's, okay, we need to re-sign into Wi-Fi. Sorry, technical difficulties.
At least, yeah.
Success. We try again. Okay, nice. So Pixie detects that we edited some C. It's like, oh no, we need to rebuild NumPy. It might have changed. So it starts rebuilding NumPy. It doesn't rebuild the entire thing. Maison Python detects that we only need to rebuild some parts of NumPy. So it does all this. It's not literally instant, but it is kind of fast. So yeah, remember this is just the one line of code that we changed here. But the great thing is that you don't need to know anything about CMake or build systems or anything. You can just run IPython like normal. Let me put the mic down. So yeah, this is not right. But if you're looking closely, you'll see up here, this is not the normal Python. Remember I said we're using Python from source. Specifically, this is my fork of a recent Python release, 13.6, called Evil Python. I don't know if any of you know, well, lots of you do, if any of you don't know about this Easter egg in Python itself. You can run this in your own terminal, import this, but it might look slightly different for you. Yeah, apologies to any Dutch people caught in the crossfire here. This is just inverting the Zen of Python. Yeah, so that's kind of a really cool demo of what Pixie can do for you. And this new stuff that we're just building right now, where you can have a workspace and all of your dependencies in your workspace, you can mix around stuff from Conda Forge, stuff from source, and when you don't edit anything, it will just all be super fast. When you edit things, it needs to recompile. If you're working in languages other than Python, it can do that for you. And again, it's kind of fast because everything's written in Rust. How is this working behind the scenes? You have a Pixie manifest called the pixie.toml. You define a package. So I say, hey, this package is NumPy. The source is here. This is just a big workspace. We have a few libraries in here. and we have like the entire NumPy source, just a Git submodule here. We also tell it, hey, this is Python, we want to use Pixie build Python, this is like a build backend that we've made a prefix. And we also say, like, these are the build dependencies that I want you to install, and then that's all we need. We also can define an environment like this, so I'm just saying, use the NumPy that is right here, and that just is pointing to this NumPy package that we've defined here. And yeah, also use the Python that is in this other folder in my workspace. And yeah, that kind of all works nicely. What else can you do with Pixie? New contributors. Okay, we're done. A ton of stuff.
Yeah, thank you.
Okay. Thank you, Lucas. So the next one up is Christoph, and yours can start preparing.
Very good. Hi. I do like this, you see.
Okay.
All right. Hello, everyone. My name is Christoph. I work at Applied AI, like Janos, and would like to bring some attention to one of our latest open source content. And who of you has heard of the AI Act, UAI Act? Some. Who of you had a look into the AI Act? Very few. Yeah. And there's a good reason for it. It's annoying to read it, because as an engineer, you're not used to read legal text. But unfortunately, beginning next year, if you like develop AI systems, you somehow have to get in contact to this stuff, right? To this legal requirements. And we thought of, okay, because it is somehow annoying, engineers don't want to, we do it for you, like as a starter, and publish this and make this free and make this available. So what is it about? We have a showcase, very simple system, but it's a high-risk system, classified. And we have a reference implementation connected to this, but the more important part is we wanted to connect the requirements, the legal requirements, to actual engineering practices, so actionable items you can do and components you can develop, and the other way around back. So if you know how to develop something like model monitoring, you're already in a good position to be compliant to certain aspects of these AI. And this is what we wanted to bring across. If you're doing good engineering practice on a close to production level, developing AI systems, you're on a real solid fundament for compliance to this new AI. And you can scan this QR code. One moment. This will bring you to the website, and there's the link to the GitHub repository. Everything is free, open source, and you can use it also in a commercial context. Right. Thank you.
You can probably just watch the time.
Thank you, Christoph. Now it's Jost's turn, and Alexander can get ready.
Just a quick conference announcement, if you haven't had enough of meeting people in real life yet. In about 3 weeks, September 9 to 11, we will have the Research Software Engineering Conference, RSECon, in the UK. In-person registration is already closed, but there's still the possibility to register to participate online. And this is open to people working on research software in any language, not just Python, but there is a large Python contingent. And it's also open whether you're in a university or academic setting, or whether you work in companies on research software related problems. So please scan the QR code, and maybe I'll see some of you there. Thank you so much.
Thank you, Just, and now Alexander. And this will be our final live intro, according to the spreadsheet. Okay. It's like I said, so okay. So,
Alright, is it okay if we have time?
yeah.
So you all see my ID up there. I'm going to talk about machine learning from the 19th century, which is my favorite topic, and I'm not going to show you 100 ways to fit machine learning from the 19th century, but a handful of them with some comparative estimates. And so basically what we start with, we just generate a couple of data points, right? And I have to click because one hand is full. And okay. And basically, so what we end up with is the dependent variable y on the left-hand side after some time, and x tilde, which is a very sparse matrix of around 5 million observations and 60 covariates. Yeah. And so this we want to fit now. And then there's basically, first option is direct attack. Yeah. So we have this implementation, just a normal equation, we invert x prime x, and do a little more. And then we run this 3 times and see how long it takes. And just here we print the point estimate is around 0.10 and 1.5 seconds per iteration. So reasonably fast. So then I think, okay, we can go faster. We go with the Kent routine in SciPy. Okay, and so this is basically what you have here, SciPy linear least squares. Pack driver Gelsey, this is what you find if you go to Stack Overflow and ask how do I make this as fast as possible. But it isn't fast at all, right? It takes a very long time, and I don't know why. So if anyone has a clue why this takes forever, please tell me about this. Yeah. So while this is running, we can think of another strategy. We could just use a sparse solver, and this is just the same thing we did before. And then we run this, and basically here, okay, we get the same estimate. This took around 20 seconds. Yeah, the SciPy implementation. No clue what's going on. And the sparse solver, we run it, goes reasonably fast, and then there's also an alternative sparse implementation in SciPy sparse, and that also will be reasonably fast. Okay, so now I think we've had 4 different methods of implementing this, and every time we got the same estimate. Now, obviously these algorithms, they will not scale if your data set gets very big. You at some point cannot fit it into memory anymore. That's why you use the sparse regression. There's one other trick that you can do. You can actually run batch jobs. And so this is implemented very simply here, where more or less what you do is you chunk your data set into pieces, you solve the problem to some degrees in smaller pieces, and then at the end you bring it all together and get your regression estimate. So this is kind of what you get here, and so this is very nice if you have a lot of data. You can fit basically a regression on a very big data set, and it doesn't fit into memory if you use that. Okay, and so here we get the same estimate reasonably fast. Then, this is my personal favorite, there's an econometrics trick from the 1930s called the Frisch-Borg-Lobel theorem, which basically consists of projecting out or meaning the dependent variable and x by this vector of fixed effects, and you have this implemented in PyFixS. And then we can run this through PyFixS, but we have to JIT compile first, so this is a number, see how fast this is. Oh, this is very fast. Okay, so very nice. Okay, here's another method from the 30s. Last thing I want to show you, which is I think something very interesting, is we can use a compression strategy to actually fit this data set really quickly. And so basically what you have at the end of the day here is we use a polar data frame, we have to do a little bit of work, So here's a Polars data frame, here's one aggregation, we compute a sum, we compute a mean over basically all the covariates that we have. That's more or less it, and at the end of the day, we use frequency weights to fit weighted least squares. Okay, so this is the strategy around this function here really quickly. And I have to do some preparation, right? Create a Polars data frame, then we run the benchmark down here. Okay, and you will see that after we have everything in Polars, we get exactly the same result as before after doing a group by compressing the data quite a lot. So this is cool. Why is this cool? Because if we can do this in Polars, we can also do it in DuckDB. And potentially, if the dataset doesn't even fit into memory, we just do the compression step out of memory in DuckDB or BigQuery or whatever SQL language that you use. And then we load this compressed dataset. Basically, that looks like here. So at the end of the day, the dataset we started with was 5 million times 60. Now we have it 5 times 60. Yeah, and so this is very easy to fit in memory. After you do the compression, you can do it out of memory. And so with DuckDB, you can do this quite easily. Basically, there's a lot of preliminaries here. At the end of the day, most of the action happens in this small software package that's called DuckReg that implements this Duck regression. So basically what it does, and what I just showed you in Polars, compresses the data in DuckDB. Everything that doesn't work in your local machine, you can do it out of memory. You compress as much as you can, you load the compressed data into memory, fit it in Python, you're done. And as you see, we get exactly the same result. It's not as fast as PyFixS, so this is what I want to show you as well. Yeah, that works, and it's really cool, and you can do a lot of things with that. Thanks.
Thank you, Alexander. It seems that I'm just really bad at reading spreadsheets, so it's not all about lightning talk. So yeah, please go ahead, and I think we still have it. Yes.
Okay, so yesterday we already heard a nice talk about how to make presentations like this one with Quarto. I thought I can show some of the other nice aspects of Quarto, namely in how you could use it conveniently together with Docker to make some reproducible research papers. So just as a quick motivation, about the state of reproducibility. So there was this survey by Nature where basically all the researchers said, yeah, there's like a problem with reproducibility. There's also empirical work where they looked at repos to see how many of those published code for papers reproduces, and it's like differs a bunch of across different fields. For example, biomedical science was like 8.5%, and another study, statistics even, was just 15.1%. Machine learning, 63.5, not that bad. So yeah, for machine learning engineers, if statisticians ever give you shit again, you can be like, hey, at least our research reproduces like half of the time. But this already, I think, points to that there are like tools to do this, and so the technology to achieve this exists. And I want to make the case here that like the two tools that could be combined to achieve a lot in this sense are Quarto and Docker. Actually, there's like a third important ingredient, which is data availability, right? If you don't have the data, you can't even start to think about reproduction. But since we already talked about this in our data lab tutorial, I thought I can just omit this point for now. So let's look at an example. So in Quarto, you write these QMD files. Maybe. Is that better? Yeah. Okay. You write these QMD files, which is basically markdown with some added features. And the nice thing is that if you open them in VS Code with their Quarto extension, you get this kind of notebook-like interface. So you can click on the cells, you can work with them like with a Jupyter notebook, but it's just text, so it's pretty Git-friendly. And the nice thing is you can render this directly to a document. So if we say Quarto preview, then it uses, oh no. So it uses Jupyter to run the code, and then it passes the output of Jupyter to Pandoc to render the documents. And since Pandoc is like super flexible, you can render all kinds of different documents from it. And then if we open that, we'll see like a nicely rendered document. You can generate. You can see here there was this comment added in this code cell. So this will generate a label and a caption, and you like can cross-reference this label, and you can add bibliography and so on. All these nice things. So now about adding in Docker. So another nice thing about Quarto is you can define projects, and you can define project configuration in this quarto.yaml file that defines the rendering behavior across all your files. And what you can do is you can define, for example, pre-render scripts that will run before the rendering of every document. And what I did here is just write a simple bash script that checks the YAML header of the file for this Docker entry here, and then downloads the Docker image to render the file in the container. So maybe let's just first run it once without the image, just to see that it doesn't work. So this should give an error since I don't have R installed. Right? And now with the container, it should work because now it runs in the container, then the cache outputs are saved, and then it still runs once again on my machine, but then Quarto recognizes that the cache output already exists and uses it. And now we get the rendered document.
And so now, Anatoly, are you ready? Okay, Anatoly, and I think we have one more to Jorge. Is it the correct pronunciation? Okay, and I think that's it.
Okay. Oh, it's not confidential. Okay. But yeah. So basically, I wanted to talk about the product that we developed, open source library, to speed up scikit-learn to Lex, to speed up scikit-learn. Basically, if you have some classical machine learning pipeline, it's like only a few reasons why shouldn't you use this library, because you can get free speed up. So it's really easy to use. So you just install it via pip. Then you can either use this patching approach, so you just import patches parent function and run this before your code, and then you just use normal scikit-learn code, and for estimators that we optimize, the optimized implementations will be used. Or if you don't want to use patching approach for some reason, you can just import the estimator directly from sklearn's repo, and let's do a short demo. So we have here a random forest training and fitting, training and inference, and now we import it from sklearn. So let's just run this code. So it's training. Let's wait for some time. So okay, training took 11 seconds and calculating prediction took 11 hundredths. And let's just substitute it with this. So just this fix in this code. And it's 2 seconds, right? So it's basically a free speed up. Because, yeah, when we check that the accuracy of predictions and the predictions itself, they are the same. So we have some CI workflows that check that you don't get accuracy degradations. So here is the link to the repo. Here is the link to my email. If you like, you can check if we have if the estimators that you need is already optimized, you can just use it. If there is some other estimator that you need and that is a bottleneck in your pipeline, and you really, it's really your pain, you can find me or text me. Maybe we can optimize it for you if it's really needed for some practical use case. So yeah, that's it. Thank you.
Thank you, Natalie. And, go ahead. Just one more announcement, so please, sprinters, get ready for your very short elevator pitches.
Okay. You should see it now. Oops. Okay, so let me share. It's going to be a bit different from the usual Python topics, but this topic is titled, Do You Want Some Pork Chop? And I hope that by the end of the talk you understand what I mean by this. So let me start with a very quick question. If you notice the latest missions, a spacecraft going to the Martian planet to Mars, you're going to see they're launching and arriving more or less kind of the same dates, right? So why is that? Is it because the weather maybe affects the launch? Is it because there are low taxes in Mars and everyone just wants to apply for that? Or is there a Python conference there? Probably there is another reason, right? So before understanding the reason behind this, you need to understand how to navigate through space, and for that you need to solve what's called Lambert's problem. So if you want to go from A to B in space over a finite amount of time, that's navigation, right? You need to solve this problem. It's like basketball, but at planetary level. You know Mars is going in that direction and you want to pass a spacecraft or the ball. You cannot just target at where it is right now. You need to target at where it will be, right? You pass the ball and Mars will intercept it at some point. So you just pass the current position, arrival position, time of flight, and it's going to return you the velocity. Why is that? Because if you have 3 components from your position and 3 components from your velocity, the whole state is defined. You know the orbit. That's the way we represent orbit. So I created LamberHub, which is a small Python library containing all these algorithms for solving the problem. And there you have it. You just need to pass the gravitational parameter from the sun, which is a constant, the position, and some other options if you want to tweak a bit more. And that image shows like an intercept orbit to this Oumuamua interstellar object. And the cool thing is that if you parameterize the whole thing and you solve Lambert's problem for every combination of launch and arrival dates, you get this nice contour plot that are called pork chop plots because somebody maybe was hungry and thought the shape was resembling to a pork chop plot. And you'll see that what we're representing here is like the fuel consumption, somehow the energy, and there is a low energy zone, and you can see that most of the missions are targeting at those launch and arrival dates. Now there might be some other constraints like maybe you don't want to wait that much time, you want to launch before, but it's a trade-off. And I think this is where I can apply all the knowledge I've seen at this conference of parallelizing for all those multiple points and maybe using the optimization tools that were presented here. So hopefully the next line in talk will be about improving the computation for all this, and I hope you enjoy it. Thank you.
Thank you so much. So now, please, all the sprinters, if you could just like form a queue in here, so that you can talk one after another. And because we have quite a tight schedule, please try to keep it like 30 seconds, 45 seconds max. So.
Now.
Okay, so
not yet.
no.
Please. Okay.
Okay.
So sprints start tomorrow at 8 o'clock, not 10 as it was indicated in the schedule previously. The reason is simple. We negotiated the coffee for people who had badges. So if you go to the bistro and show the badge, they will give you coffee. But they don't work since still 8 to 4. So you need to be there at 8. But you can start later if the presenters will come later. And we still have time to 6. So now we can go with the in order on the website. Okay.
Just one small remark: if you don't know where the bistro is, it's just when you leave this room, straight on. It says bistro.
Yeah, I don't think we have any specific teams, but we have some issues that are labeled as printable, and hopefully some of them actually are. So if you're interested in this, we're around. I think we kind of overlap with SciPy to help everyone out. And yeah, just reach out and make sure that we don't go into rabbit hole. That's the biggest thing, but yeah, hope to see some people.
Okay, hi. So we're all here for SciPy, we're all here for open source. Let's help out a bit and see what works.
Okay, pretty much the same procedure. I don't know if we'll be here at 8, but we'll try. So senior here, I will say that we have 3 things. So we have scikit-learn, we will have imbalance run, that we might have like a couple of things to do there, and another package which is CRUD afterward that will come. Okay. So if you want to see a bit the ecosystem related to machine learning, we'll be happy. We'll be like 4 or 5 of us. So if you need any mentorship, we'll be happy to have you. So that's still us. That's not.
Well, I can guarantee you I will not be here at 8. So yeah, if you need to visualize stuff and you want to either learn how to use Napari to do that, or you want to make a plugin or extend it, or actually contribute to Napari, come to the sprint. I wrote down a few things here so you can look up on the website for some details, but whatever you want to do that's Napari related, we're happy to help.
Hi, so yes, we'll do a packet sprint. It's a regression package for high-dimensional fixed effects. If you know Rust and want to help us optimize some of our algorithms, please come over. You can help Christoph, who's already been working on it. Another thing that we want to tackle, we have implemented a quanta regression solver. We think it is faster than what is implemented in scikit-learn. We'd like to contribute, but before we do that, we have to convince the maintainers and actually show that what we've implemented is faster. So I'd like to work on that tomorrow as well. Okay, thanks.
Yeah, Array API Extra, one of the Array API libraries. We have some nice easy issues, we have some more complex issues, so you can come and make a PR for that. Also, if you want to work on the Array API but for your own projects, I'm happy to help out with that. And yeah, you can also come and talk to me about Pixie too.
So yeah, I'm a +2, and we've actually decided that because there's so much Array API expertise here that we would like to ignore all this and have you work on Array API implementation, because we didn't realize how difficult it was, and so our attempts to implement or to move over to the Array API are probably quite insufficient. So there'll probably be lots of low-hanging fruit, which might be of interest. So.
Yeah, first of all, who knows Notion or is using Notion, like a tool to organize that? Okay, there are a few. And yeah, this is just a little hobby project of myself, like a Python client that makes it really easy to also work with your whole content. And yeah, I thought if anyone is interested, come and talk to me tomorrow. I'll be working on some of the issues. Currently I'm the only maintainer, so an only contributor. And so if you're interested, just talk to me. I'll be here tomorrow, maybe also at 8, around 9, maybe. Cool.
Hello. So, if you want to run Python on something nice and small. You can start with this one, which is maybe hard to see from the back, but this will run MicroPython, and several devices I have have a bunch of sensors on them. We have accelerometers, I have a multispectral light sensor, related things like that, also microphone, I think. So come and play with the smallest Python there is, and yeah, it'll be fun. Bring a USB-C cable if you can. Thank you.
Okay, thanks to all the speak leaders, and this is all we have. And now a bittersweet moment, the closing of EuroSciPy 2025. A closing of EuroSciPy 2025. So first of all, thanks to our sponsors, and please do it again for MDPI. And another round for Anaconda. Without our sponsors, of course, we wouldn't be able to do things. So all you see that is nice, thanks to them. But also thanks to all our community partners and to bronze sponsors who also help. So institutional sponsors helped us with infrastructure, with the venue, and administration, so thanks to them as well. So of course we would like to be as inclusive as possible and invite people who otherwise wouldn't be able to travel or buy tickets. So thanks to our financial aid sponsors who allowed 30 people to come, and we got 9 people from underrepresented groups, 3 from outside of the US. So thanks again to financial aid. So you did a relatively interesting question. Okay. I want to just show one numbers. We're going to show a lot of numbers, but before I will go to this, I want to get a little bit more that we don't have. If you've been here at EuroSciPy last year, could you raise a hand, please? Okay. And if you've been at least once after COVID, could you please raise a hand? Okay. And if you've been like between 15 and before COVID? Okay. And if you have been at EuroSciPy in 2008, would you raise a hand, please? So this is the first number that I wanted to show. This is Mike. He is the founder and one of the organizers of EuroSciPy. Please give him a welcome. So Mike has prepared a bunch of numbers, and we're going to share them with you. So Mike, please take it away.
Yeah. Okay, since we are at a scientific conference, we are number crunchers. I'll show you a few numbers, and we use some statistics, so they are pretty fresh. I cannot guarantee that they're totally correct because, you know, now the data kind of a mess, but it should be kind of okay. And one of them is the submissions. So you can see the blue line represents how many submissions we received, and very easily there's this yellowish or whatever line it is, and the red one are the deadlines. So we had a deadline, then we have an extended deadline, and you see by far the most people submit a few hours before the deadline, which is very obvious, and you see how this spikes on. We had like 124 submissions. There are a few submissions after the deadline that were like, they have the keynotes and there are other things that we move something around, so that's why sometimes we have a little bit more than there, but we have about 124 submissions in total.
In other words, as the submitters, you gave us a very hard time.
Yeah, then we try to break down the numbers. So these are submissions now we realize only 110 because we took away the withdrawn ones, and this is one of the analyses we looked for gender. So how many, what we got submitted, and we had an optional field to specify the gender, and as you can see, nearly half of them didn't specify the gender, And then that's why I made another plot where I took the unspecified off. And you see we had about a quarter of them are male, and the rest is female, and that's one person that clicked the non-binary. That's a breakdown of the submissions we had.
A little history behind this is that before, the only information about gender distribution we had were from tickets. So only if you get accepted to the conference, we could actually say how many people by which gender or how they would identify we know. So this year we did introduce the field for gender in the CFP. So now we do have these statistics about the submissions. So thank you to everyone who submitted the talk. Without you, it wouldn't work.
Do you have the breakdown between genders after the exam?
Give us a second. Of course. So one thing that we did as well is we introduced the peer reviews. So when you were submitting the talk in the CFP, you could indicate that you would like to participate. So 40 people specified that they do. 22 we added to pre-talks to actually start reviewing. 16 of them started reviewing. And they, in total, provided about 445 reviews, which in the past, we had to review everything on our own as a program team, which would usually indicate up to 100 submissions to be reviewed per person. This year, people reviewed up to 50, but they were asked to review around 30. And you see? Yes.
50 was the maximum, and the minimum is 1, and that was
Yes, we assigned them about 20 and then asked to review a little more if they have time. So some did have time, some didn't. So the same pattern, there is no strict deadlines there because they were moving constantly, but you kind of can see where they were. So only when we were introducing the deadline, asking the reviewers to finish their reviews by specific date, we got a bump, and then we realized that, oh, okay, we don't have enough reviews, we need to do another deadline, nothing happens until that deadline, and so on and so forth.
You know, the programming paradigm is a deadline-driven programming.
Exactly. So thank you to everyone who reviewed.
And there are some more things that I took apart the submissions by state. So we had we took about more than half of the submissions were taken. We had to reject some because we didn't have enough space. So we had very high quality. Actually, if you look at the stars, actually they are also high rated. So, and then we had a few people withdraw for different reasons, and there are some that cancelled.
Which, in other words, means that you also give us, all those people gave us a hard time. So cancelled means that the talk or the poster was already in the schedule and on the website, and they either didn't show or we had to cancel. But some of them cancelled because of obvious reasons. They couldn't influence, like visas, but as some others, well, just probably couldn't make it. We didn't were able to contact them yet. So in 14 withdrawn proposals, which is also was very difficult to fix, but we did it.
You see the ratings are very high, so more than 8 out of 10 for the ones we accepted. And I also did the mean is a little bit less, and I did the mean overall, and the mean overall is more than 7 also. So also even including the rejected ones, we are over 7. It was a very hard decision sometimes to reject, but the problem was the space. We didn't have too much space to.
Yeah, so you can read more about our methodology for the reviews, how we structured it on our social media. But yes, that was a lot of difficult choices, for sure. Here's the submissions per gender.
Yeah, so I tried to take this apart. So these are the numbers of submissions. You saw the other one, and now it's a table that how we did it. There's how many accepted and rejected. And then this is maybe easier. This is how many percent you see it's pretty much, for the one that specified the gender, is pretty much half. This one number you took, that's about 100%, and then most of them are non-specified, and this was 7%. So but everything was blind. The review was blind. Nobody knew the gender or anything like this. It's just how it came out at the end. But you see the numbers are pretty evenly distributed. And since the end is pretty small, yeah, so 1 or 2 more makes a big difference in terms of percentages. So there's some randomness in there.
Yes, we did try our best to make reviews anonymized, so a lot of fields were hidden, including the gender, including the names, of course, but sometimes people sneak in their names in the description or in GitHub. Those are really difficult to navigate. But we think it's very much related to the reality. And we had similar numbers in the past, but we couldn't prove that because, well, we didn't have the numbers of people who was not accepted. So another one that we introduced was the AI usage. It also wasn't visible to the reviewers, but we wanted to see if it influences the probability of being accepted.
Yeah, and you see it's about half of the people didn't use any AI, at least that's what they clicked, yeah. And the other one used AI, and there's different ones. The green one is only for the submission, and the blue one is only for the project, and then the other one, that's another, they use it for the project but not for the submission, which is a very small one. And I run the same thing for the rejected and confirmed, and it's always about 50%, 48, 52, so it's always but it doesn't change much, so there doesn't seem to be a big influence on the acceptance or rejection rate.
So another thing that we wanted to track this year is whatever we have an original content, whatever the people present something for the first time here at EuroSciPy. So we didn't ask them about this. We don't track if people said it, what they said is true or not. But we had a field in CFP. And those were visible to the viewers, though acceptance were probably influenced by that. Well, we asked reviewers to actually do that.
Yeah, so about close to 55 or 60% are not present before, and there's the other one. This is actually the question we asked there, and then of course they don't fit there, made it a bit shorter. And some of them submitted it to some other things, which is usually what we do, and only a few being present for before.
So similarly, we wanted to know what's the relationship between the person who is presenting and the project that they are presenting. So if they are a maintainer of the library and they present whatever they are doing a feature there, and it was a multiple choice question, so it's a little bit more difficult.
Yeah, so there's a lot of different categories, and I just filtered out the ones that contain original author, which can have different there, and it's about 3/4 of them are original authors, and the other one are like active contributors and so, but pretty much everyone was involved in this project, more or less.
So as you can see, we have pretty much the original content from original authors. So thank you very much for everyone who were presenting anything during EuroSciPy this year. And of course, thank you to our keynotes, without whom we wouldn't have much of the reach in the social media, and also many people wouldn't come probably, because every time we have it, some people always come only for keynotes. I would also like to thank the leaders of the maintainer track. So give us a round of applause. So we had 8 beginner tutorials and 8 advanced tutorials as usual. So thank you to everyone who were a tutor. So and everyone who were just presenting a talk as well. And we had a lot of numbers in between, but we decided to spare the group. So 11 posters that we were presenting. 17 lightning talks, and lightning talks. presenting lightning talk is incredibly brave thing. So if you did, thank you from organizers and a lot of us from organizers, and I believe from other attendees as well, believe that lightning talks are a jewelry and basically the best part of the conference. So thanks again. So for the code of conduct, we didn't have any violations so far, but it's not the end of the conference. Everything that is happening, including the sprints, and also everything that happens online is under the scope of the code of conduct. We don't aim for no violations, no reports. We aim for everyone to feel safe and heard of if they feel that something is wrong. So scan the code, read the COC there if you still for some reason haven't, and thank you to our COC team.
Okay, more numbers?
More numbers?
More numbers. So took me quite a while to find it out because it's the system where you buy the tickets, sometimes you sponsor them by multiple tickets and so on. But I'm pretty confident that they have 130 people. That's what I came up with. So maybe 128 or 132, but there's about 130 people that attended the conference here, and some people attended only the tours, which is very few people that are not here. Most of the people that attended the tours are also here, I think more than 90%. So I didn't break this down because they have many different tickets for different early bird, late bird, organizers, and so there were different categories. Yeah. And I broke it down by country, which was a nice thing. So, of course, since we're Poland, the most are Poland, and then Germany is next door, and it's the biggest country in Europe, so this makes sense. So you see, this is very, very simple. So if you've been in Europe, I think they are pretty similar breakdown. Only the biggest part was Czech, because we have been in Prague. So very similar kind of distribution, I would say. The Gasland, Germany, and UK, usually that's very typical.
It's like Python is the second best in everything, and Germans are second most visited nation.
Okay, and this is a level of Python knowledge. We have to ask several things on the team. We have quite a big part of people that are pretty advanced Python. People use Python for a long time, and you put this at advanced, and beginners are the minority, which because I was teaching very basic Python tutorial, and only a few people, which reflects this.
But we really appreciate that people who don't know anything come, and we will always have a place for them, and we will always try to make sure they can start their career here.
And then this is now the gender breakdown for the attendees, so that we get out of the system of this 130 people here. So it's about a quarter female, and the rest mainly female, male, as you can see. And some people didn't want to tell what gender they have.
Question?
Yeah.
Do you know why we do not want to disclose fraction is so much lower for attendees than for submissions?
Why? You thought we will respond? We will throw it at you. Why? No, we don't. No.
Maybe frankly we have to ask a slightly different question. I don't know. So I have to check if the questions are exactly the same.
No, questions are different. They start a bit differently. So
yeah, maybe how you formulate the question has influence. I don't know. So.
And also maybe because when you buy any ticket, not presenting yourself, and when you're submitting the talk, you're putting some information about yourself, and it's going to be public as well. But we can't check for sure. So this is another number, which is also shows how difficult it was to organize the conference.
Yeah, so the ticket sales is a little bit, admittedly we are a bit late, but yeah, there's a lot of reasons, like we are in Poland, and the institution that's doing the finances is a German institution. We had to get a Polish tax number, and a lot of all those details that end up make it difficult that there was late, and that's why. Yeah, then we used a new system for the tickets, which is called pre-ticks, and then there was a lot of things we had to automate, and it took longer than expected, as it always does. So there's a lot of lot of good excuses we have that we are late, and that's why you see whenever then you send out the vouchers for the speakers, and we had a speaking jump at the very end of the conference.
So thank you everyone who attended, who watched the YouTube videos, which we didn't actually advertise, but people found them. Thank you everyone. Without you, again, that wouldn't be happening. We are doing this for you. So, what do you think about EuroSciPy 2026? Where should it be and which dates? Well, we kind of haven't settled for 100%, but we really want it to be here again, roughly the same dates. But we do need your help. So we don't have enough people to support local organization. So if you are from the university or watching it online and want to help us, that would definitely would be much appreciated. So just write an email or approach any of the organizers, join the organization team. So, and we will have call for venues, but already for 2027, which is something that we finally started doing. So watch our social media and please propose your venues, propose to be local organizers in 2027. But the best thing to start is join the organization team in 2026. So you will learn how things are working, what are the processes, what the challenges, and then it would be way easier to bring EuroSciPy to your local town. So another announcement, please. We have a channel in Telegram for photos. If you will share something there, we will use it on social media to advertise to get more people aware of EuroSciPy, and it will give us more reviewers, more submissions, and more attendees next year. So please do that. I know you have a ton of photos from social event, from the event, from poster session. We like them all, please. Finally, almost finally, we would like to know what you like about the conference, what you didn't, whatever we have listened to the previous feedback. That's the third year we are doing this. So we are interested, we are really looking into the feedback. We are trying to understand what could we do better. And you can also say if something is not, we haven't delivered. Maybe we have promised that we would do from the feedback previous years, but we haven't. Give us everything that you want to say. It's anonymous. And if you want to say it in the face, of course you can come to us. But there we have it in written form so we can analyze and act on it more efficiently. So thank you for all of the volunteers, and I would like to ask them to come to the stage now and stay in the front of the cathedra so we can thank you. And that includes also session chairs. If you have session chairs, please come here as well. All of these people as well. So we have a lot of organizers, and some of them unfortunately couldn't make it to the conference, but this presentation, for example, was edited by, I think, 6 people, and majority of these, all of those people actually, and some of them were editing this while we were at the social event, relaxing, and they were working hard on this one, so let's give a round of applause to them. They're watching, I'm pretty sure. I also would like to call to join us here everyone who was involved in organization locally. Local organizers, please join us. So without local organizers, of course, we wouldn't have anything, and of course, we wouldn't have pizzas. And of course, no one would, you would have to go on social event and pick up pizzas yourself. So thank you again. And here are the regular organizers who've been doing this for a very long time as well. Please come to the stage. What is that? Esther, come on. Okay, so she wants to sit there, but please give her a round of applause. And this is it. So we want to say goodbye. Thank you for coming again. This is the team. This is what it takes to, how many people it takes to make this conference. And this is actually a pretty small number this year. We are very scarce, so we need more. Please join us. I would like to ask you to stay where you are and maybe group a bit. So we will go now to the stairs with you and have a group photo. Or you can do that. We can do that. I'm not sure if you can switch it though. Yeah, we will all go there and swap. Okay, I feel like I'm not very poorly organizing things. Who's going to take any photos? I don't even have a phone. I also had it somewhere, probably, but yeah. The problem is that...
It's a good way to not be in a picture.
Okay, true.
Okay, so I need you to act as if you enjoyed it, okay? Act
as if you enjoyed it.
A bit more, please. Please go on. Okay, I'm going to take a video now. This is going to be threatening, so please, did you enjoy it? Yes. Thank you all. Until next week.
So yeah, this is actually the last slide. That's it. Thank you. Thank you again. Goodbye, and see you on Springs tomorrow. You can pick up some jetons there. Oh, you can ask for them even now, but they will be there. Coffee will be there. Please call and let's have some fun. So if you haven't catched it, the screens are in this building. There are numbers of this. It's the third floor where there was the focus room and the room